Alright, welcome to the video on significant figures. In this video we are going to go over the fundamental concepts of significant figures, and we'll also talk about the basic rules. It's important to know that this video is meant to be a comprehensive overview, and if you need more time or more practice, you'll be directed to other videos that will give you those things. All right, let's start off with what are significant figures. So those are the numbers in a measurement or calculation that count in terms of precision. So let's say, for example, we have this red line and we want to measure the length of it. What would we do? We would take a ruler, and this being a science class where we use the metric system, we would use the centimeter side and we would measure the length of the line. Now notice that this line falls somewhere between 3.8 and 3.9 on the centimeter scale. And if we blow it up a bit and try to estimate, we would say, that looks close to about the 0.82. And the way that I did that is just divided the space between the 3.8 and the 3.9 in my mind by 10. And in that scale in my mind, that looks like it's about 0.82. So in getting that measurement, that last digit, that last number, that 2 there, I estimated that, and that's called our uncertain digit. So when we're talking about significant figures, the last digit is always the uncertain digit, the one we're always estimating. Now, what does that have to do with precision? So the numbers in a measurement or calculation that count in terms of precision is how we define significant figures, right? So what does that have to do with precision? If we're measuring this same line, the first time I used this ruler with centimeters and millimeter markings, let's say the second time I measure the same line, but this time I'm just using a ruler with centimeter markings. So I'm still going to have to estimate where that line is, but in this case, it's a little bit harder to do because I don't have those millimeter markings. And so I'm just dividing the space in between 3 centimeters and 4 centimeters by 10. And when I do that in my mind this time, that looks like it's around 0.7. So I would say it's 3.7. That last digit again is the one I'm estimating, so it's my uncertain digit. But if you look at the two measurements now, you will notice that the first measurement is more precise than the second measurement. So that just means that whenever you're taking a measurement, if your uncertain digit is further to the right of the decimal, your measurement is more precise. All right, so just big picture ideas about sig figs. They are just essentially the numbers that matter in our measurements or calculations. And again, the way that it relates to precision is if your uncertain digit or your last digit is further to the right of the decimal, that means your measurement is more precise. Okay, now why are they important? Two main reasons. In addition to telling us how precise our measurement is, they're also helpful in helping us know where to cut off numbers in a calculation. And the reason why that's important is a lot of time we take our measurements and we use them in calculations. For example, if you measure the mass and the volume of something, you can use that to calculate the density. Each of those measurements have uncertainty, and when you do the calculation, they bring those uncertainty with them. So you want to make sure that you have the right amount of uncertainty, and it always should be that last digit is the one that you're estimating. So we need to know some rules in order to figure out like where to cut things off in our calculations. And there are two basic rules: how to count significant figures and what to do when performing calculations. Let's start with counting. So essentially all numbers in any measurement is significant, except for 0. They're sometimes significant, sometimes they're not. So let's talk about when zeros are significant. there are two main cases. So if you have a zero that's between non-zero digits, like in this example here, the zero is between a 2 and a 2, so this zero is significant. And if we're counting which numbers are significant, it's all of them. So that's 1, 2, 3, 4, 5 numbers in total. So we would say it's 5 sig figs. Another case where zeros are significant, meaning they matter and they count, is zeros that come after a non-zero digit and a decimal place is present. So if you look at this number here, there's a decimal at the end here. And whether it's at the end or the middle, it doesn't matter. But because there's a decimal here, all of these zeros, which come after the non-zero digits, in the 8 and the 3, they count, they matter. So when we're counting, we would say 1, 2, 3, 4, 5, 5 numbers that are significant. These are cases where zeros are not significant. So any zero that comes before a non-zero digit, it's always insignificant. If you look at this number here, we see that the first 4 digits in this number are all zeros. So we don't count those, they don't count. And when we are counting how many significant figures there are, we start with the 4, which is our first non-zero digit, and it's 1, 2, 3. There are 3 of them, so we count 3. The last case where zeros are not significant is when they come after a non-zero digit and a decimal place is not present. So there's no decimal in this number. So we can't count these zeros as significant, which we did in the previous example where there was a decimal place. So in this case, there's only 1, 2 significant figures here. All right, that is how we count them, but there's a really cool trick for memorizing when to count zeros and when not to count zeros, and it essentially has to do with the map of the United States. I typically don't like tricks, but I find this one really useful because it makes this process a little bit more mindless, and you can invest your brain power in the calculations. So how does this work? Essentially, you have to remember the map of the United States and know that the Pacific Ocean is on the west coast and the Atlantic Ocean is on the east coast. And so the rule goes that if there's a decimal place present, notice the P, we count from the Pacific side, so from Pacific to Atlantic. And we always start with the first non-zero digits. So for example, in this number here, 83,000, we see there's a decimal place right there at the end. So I'm going to start from the Pacific side since there's a decimal place present, and I'm going to count over to the Atlantic, starting with the first non-zero digit, which in this case is the first digit. So that's 1, 2, 3, 4, 5 digits are significant. In the second example, we have again a decimal place present, and again I'm going to start from the Pacific side, but I always have to start with the first non-zero digit. Since all of these numbers in the beginning are zeros, I'm going to skip those, go straight to the 4, and then count over 1, 2, 3. Again, I'm going from Pacific to Atlantic. Now in the case where the decimal place is absent, there's no decimal place, we are going to count from the Atlantic to the Pacific. So here we have this example. Notice there's no decimal place. So in this case, I'm going to start at the Atlantic side. The first digit that I see starting on the Atlantic side, and I want to count over, is a 4. That's a non-zero digit, so I can start there. And 1, 2, 3, 4, 5. And then we do the same thing with this example. Again, it's 83,000, but there's no decimal place. So again, I'm starting with the Atlantic, from the Atlantic side. I notice that these first 3 digits that I see are zeros, so I'm going to skip those and go straight to the 3, and then continue counting over from the Atlantic to the Pacific. So 1, 2, and there's 2 sig figs there. Okay, so now that you've seen this trick on how to count significant figures, what are your next steps? You may be feeling like, hey, I want to see more of this, see more examples. If that's the case, then watch the Significant Figures and Zeros 1.3 video. If you feel like, you know what, I got this down, I'm ready for some practice, then watch the Significant Figures practice problems. Remember, as you're watching the practice problems, make sure you pause the video as necessary. Okay, now we're going on to performing calculations. We're going to look at addition, subtraction, multiplication, division. So when you're adding and subtracting and multiplying and dividing, the rules are different, so pay careful attention. In addition and subtraction, you report your answer in the least number of decimal places. So addition and subtraction, least number of decimal places. And multiplication and division is you report your answer in the least number of significant figures. So let's start with this example for addition and subtraction. We have 13.0198, and we're going to add to that 1.2. Notice in the first number on top, there are how many decimal places? 4, right? So this one has 4, and the number on the bottom has just 1 decimal place. So which one of these has the fewest number of decimal places? Yep, it's the one on the bottom, the 1.2. So when we get our answer, this is the complete sum, but we're going to report our answer in significant figures now. So if we're reporting in significant figures, what we want to do is use the least number of decimal places, which is, again, we're looking at comparing these two numbers, just 1 decimal place. So the final answer here in significant figure would be 14.2. Let's look over at multiplication division. So in this case, we're reporting our answer in the least number of significant figures. To do that, again, you want to look at the numbers that are multiplying or dividing, but now we're not looking at decimal places, just significant figures. So this first number has how many significant figures? Yep, it's got 3. The second number, that's a comma by the way, has 2 significant figures. So that means that our final answer should be reported in how many significant figures? 2. Great. So this is the complete product here. This is 9,824,000. We only want 2 significant figures. Right now, there's a total of 1, 2, 3, 4. Actually, I should start from the Atlantic side. 1, 2, 3, 4. So we only want 2 of those. So what we're going to do is we're going to replace the digits to the right with all zeros. And so we have now 9,800,000, and we reported that in 2 sig figs. Okay, last example here, we are dividing now. This is 8.000, so notice that there's a decimal place there. How many significant figures do you think are there? That's right, so since the decimal place present, we're starting from Pacific to Atlantic. There's 1, 2, 3, 4, 5. 1, 2, 3, 4. And then in this case, we have how many significant figures? 3. So the 532 just has 3. And so when we report our answer, we want to report it in the least number of significant figures, which in this case is 3. And this is the complete quotient, but we are only reporting it to 3 sig figs. So we're going to cut it off here. Now here's one thing that's important. Notice our answer is 0.0150. Do we ever count the first zeros? No, we don't. So in reporting our answer in 3 sig figs, you're going to skip right over those and just count starting from the first non-zero digit, 1, 2, 3, and that's where we want to cut it off. All right, last note, make sure you round appropriately at the end. And what do I mean by that? Couple things. One, if you're doing multiple calculations, don't worry about doing significant figures the whole way through. Just at the end, report your answer in the proper number of significant figures for your final answer. The other thing that I mean is that when you are reporting your answer in significant figures, you always want to round appropriately. So in this case, for this last example, we wanted to report it into three sig figs, and we wanted to cut it off at the 0. Let's say the number to the right of the 0 was an 8 instead of a 3. That means we would have to round this up to 0.151. So always make sure you consider that. All right, next steps. If you want more help on addition and subtraction, watch this 1.6 video. Multiplication division is 1.5. And when you're feeling ready, make sure you take the significant figure exit ticket. Hope you found this video helpful. Have a quality day.